Clash Royale. It is a mobile strategy game by Supercell with over 500 million downloads just in Play Store, and it has generated over $620 million worldwide in revenue for the year 2025. The premise of the game is simple. As of current, there are 121 cards to choose from, of which each player brings 8 cards into the battle, and the goal is to bring down enemy's tower while defending your own. In battle, the players have a currency called elixir, which goes from 0 to 10. The elixir is consumed whenever a card is placed in arena. Each card have different role to play and different amount of elixir assigned to it. I am Manav Mehta, a second year data science student, and according to my observations, the game has become unplayable for free-to-play players after the release of level 16. So I've decided to beat these credit card players with skills by using a technique used by pros like Riley, which is to count your enemy's elixir and play according to that. To do that, I'll be building a machine learning model that watches my whole gameplay and estimates my enemy's elixir for me. So after 2 months, the project is finally completed. I have divided this project into 6 different steps, and I'll be going through them one by one. So the first step I complete was screen capture foundation. First, I need to get the region of my game window that I'll be capturing. For that, I will use Spy Auto GUI. Now what this command does is it will tell you to go to the top left corner of your game window, and then it will give you 4 seconds of time, and it will record the position of your pointer. It will do it again by telling you to go to the bottom right part of your game window. At the end, it will tell you the position of your game window. This is the command in action. First, I took my pointer to the top left, then to the bottom right, and I got all of my coordinates like that. For screen capturing, I have used MSS, and after putting in the coordinates from last code, it runs perfectly. But this version has the classifier already applied to it, which I did in the final stages of the project. As I didn't use bash for the project, I can't do a version rollback to it. Now the second step is the dataset collection. Collecting data was relatively easier compared to others, but it also took the longest time. It almost took me a month to complete, also because my exams were going on at the same time. But collecting data for 121 different classes individually for each of them was very challenging. And there are also many variances for a lot of cards, like there are evolutions and heroes, and there are also golden cards for some reason. So I started by creating a log in Excel sheet which includes all the gold variants, evolutions, heroes, and also abilities/variants. The special variants only includes the Spirit Empress in her walking form. Now, as to what data to record, I'll be using a very minute detail that most players might miss, and this small thing will also help the model significantly in distinguishing between the cards which are already in the arena and the ones spawning in right now. And that small detail is the clock, which appears when a card is spawned in the arena. Blue for your own and red for the enemy. I recorded each troop while the clock was on them, and this is how my setup looked like. So what I would do was, my game is running in the middle, where I would start a friendly battle with my other account. After the battle started, I would select a small region on the arena where cards would be dropped. Then I would copy the name of the card that I will be dropping from the Excel sheet on the right and paste it into the command prompt on the left. The code had a delay of 5 seconds, giving me enough time to drop the card from my other account. When the card drops, the code will start taking 30 screenshots of only the region of the card, saving me the trouble of cropping. And each of the 30 images would be labeled by the name of the card. After that, I would go to my folder and delete the noise images, essentially performing data collection and cleaning at the same time. This is the program in action, literally the best way I could have collected so much data. After marking the drop zone, it will start taking 30 screenshots of the card. I can see the screenshots in real time on the right side of my screen. and I've added a bit of interval between each screenshot so that not all of them are instantaneous, and it will add a bit of variety in the data. After having a sweet treat, I started working on the data again, starting with all the normal troops and buildings. So I've collected the data of all the non-champion troops and buildings, though there were some unprecedented hurdles. Like, did you know the Three Musketeers doesn't have a clock? Maybe they forgot to add it after remodeling them. Or why are Royal recruits so long? I had to change my dropping zone for them. And Spirit Empress is as bad as the E-Wizard. So I had to make some changes in the data set, and they almost looked identical in all the images. So I just completed the last batch before I went on with champions, and this whole batch is ruined just because of a small mistake. So almost none of these cards were captured properly except this goblin machine, just because my game was not full screen, and the full screen only made this much of a difference. Just with the one tile shift, my whole batch is ruined. The problem with champions is that I'm at 8k trophies, so I can only carry one champion to the battle. So I have to battle multiple times to record every single champion for my data. So I've decided to record all the champions that I can today and record their abilities on the third day. And I don't even have half of the champions. I don't know what I will do tomorrow. So I have to see something for that too. I've recorded all the evolutions, champions, champion abilities and heroes that I had. I have to move on to spells. Now there are two types of spells that I've classified them into. First are the spells that are shot from the kingdom, like fireball, rocket, giant snowball. And other type of spells that just appear on the field. So for the first type of spells, what I will be doing is capturing the moment when they are shot from the king tower and adding that to my database. And for the other type of spells, I still don't have an idea what we can do about it. Step 3 is where actual machine learning stuff starts. So I will be building an image classifier. But first I have to prepare my data to be fed into the model by separating them into parts which will be used for training and testing. Now my data was stored in all these different random folders. So I wrote this script for it. And what this script does was collect all the images from these folders and store them into a single folder named dataset. This dataset has different folders like test, train and evaluation. So a training data is stored in this folder, and this consists of all the cards by their name. There are archers, baby dragons, and 70% of my data is stored in train and 10% in test, and the rest 20% is stored in valuation. So for the first step of machine learning process, I've downloaded 4 libraries. First is Torch, which helps in build and train the neural networks, and Torch Vision, which will help in image classification. And then there's Pillow for image processing, like rotating the image, resizing the image. And at the end there is TQDM, which helps with the progress bars of loops and other stuff. This is the training script which trains a lightweight ceiling classifier using MobileNet V2 through transfer learning to recognize cards from image model. Its inference time for CPU was around 5 to 10 milliseconds, and for GPU it was 1 millisecond, which even on a weak laptop is totally negligible load. Well, of course my laptop is not weak in any regards. It applies data augmentation to improve generalization, freezes the pre-trained backbone to prevent overfitting, trains only the classifier head, evaluates performance on a validation set, and saves the best performing model along with class mapping for real-time inference. Well, to put it in non-technical terms, think of it like a security camera with facial recognition. The security camera runs all the time, but facial recognition only activates when a face enters the frame. You can see the name of 113 different cards on top, of which the model is trained on. The best validation score I got was 90%, which is very strong. Okay, so this is an image of the bomber from the test data, and this data was not fed into the model and not used for training. So now I will use the script to test if it works or not. So this is the part of the image. That's the name of the code. We'll run it. And it's 99% sure that that's a bomber. After training and testing the model, I started testing on real-time gameplay. And that's where I realized a major flaw. The model was falsely detecting a goblin barrel on the field. I thought maybe it was because of some noise in goblin barrel folder or because of low confidence. So I decided to change it from 80 to 85. But it was still having the same issue. I also checked cards folder, but there was no noise image that could cause this. So I just realized that the classifier that I've been building for so long won't work with Clash Royale because classifier only detects the cards that are dropped on a certain part of the arena. But in Clash Royale, cards are dropped everywhere in the arena. So a classifier won't work for that. So right now I'm thinking of making a object detection model of YOLO. So after realizing limitations of my original model, I started working on a whole new object detection algorithm, which is way more complex than my model and also works way better. It is called You Only Look Once or YOLO. But later at midnight, while researching about it, I discovered another problem. So YOLO won't work because to make the YOLO work, I have to first upload my data set into RoboFlow. And the data set, for the data set, each card should have at least 30 images. And there are like 100 cards. And each image should be cropped without any background to it, to the precision. So that would be around 3000 images that I have to edit for it, and I don't have that amount of time. So what I'll be doing now is going with my classifier and writing a new code which will detect any movement on the screen, and if movement is detected, then that part of the screen will be fed into the classifier, and then we'll see how it works. After deciding to go with the motion detection script instead of YOLO, here is the architecture diagram of my whole project. First, I will run motion detect demo using command prompt, which will capture whole game using MSS, while running a motion detection and cropping the moving region. Then it calls a card classifier, which loads the trained CNN model, pre-processes cropped image and predict card name and confidence. At the end, results will be displayed using OpenCV. This is the final stage of the project where everything comes together. I will finally be adding the elixir logic and a mirror, which is a card with no elixir's logic, and show some live gameplay at the end of it all. So I have to start working on card number 108, which is mirror. So mirror is a card with no specific elixir value. It mimics the last card played by the player. So if a card originally costed 5 elixir, its mirrored version will cost 6 elixir. And here I have added each card's elixir cost to the script. So hopefully this will be the last time I'll be touching the code. I have tuned the confidence to just the right amount. I added the mirror logic. I have added the elixir logic. If things go right, then I have to start running code when the loading ends. That's when the timer starts of 3 minutes, and elixir will start at 5. One elixir is added every 2.8 seconds, And after 2 minutes it's 1.4 elixir, and after 4 minutes is 0.9 elixir. So if things go right, then it will be a success. So I'll be starting the test number 1 right now. So thanks for sticking with me for last 15 minutes, or even if you skipped right to this part, you deserve a montage of the model in copyright-free opera music from 1829. So the model is detecting cards about 90% of the time, but it does identify them perfectly. Though there are still some problems, like it is detecting goblin machine and royal recruits on the field, but it is not deducting the elixir, so it's not that big of a deal. And I was not able to figure out how to detect some of the spells that just appear on the arena. I'm still very happy with the result. If I had more time and resources, I could have made it better using YOLO. But on the brighter side, I could have also half-assed it and used my old classifier for it without any motion detection. I did learn a lot from this project, like adapting to sudden changes and failures, planning things out, debugging and problem solving. And on the technical side, I learned about deep learning using PyTorch, computer vision, OpenCV, dataset engineering, and most importantly, ML system design. And I also learned how to record using a TN Typhoon. Now, I do have some ideas on how I can make a better version of this project, which I most probably will be doing in the future. For now, I will be working on my other projects while looking for some internships. Until then, you can connect with me on LinkedIn and Instagram. Thank you for watching. Goodbye.